Buddy, my name is Fanimo, and this is Data Mining IT 533. And before I start, I want to say a special thank you to my professor, Professor Sonia Struber. You've been really good to me. Thank you very much. Um, in this case, the first question here says that, is there a class attribute in our data set? Yes, I believe there is a class attribute in the data set. I use the HLTH as my class attribute in this instance because it has the potential to function as the int variable, and it can also be converted to factor. And yes, so that is why I've chosen it as my uh, class for this analysis in this data set. So I move forward. I say, if not class attribute, if not, what class attribute should there be? Well, I already explained that. For what political purposes would someone be interested in this class attribute? Because a class attribute that can also function as a variable, integer variables, and can also function as a factor variable, it can be of very utmost importance to anybody under any condition. So the question 2 says that list the minimum, maximum, mean, median, mode, quartile, interquartile 1 and interquartile 3, and the standard deviation for the age and non-crom attributes belonging to nearest and other. So I was able to achieve this by saying that, by doing this short thing right here, I converted my region to integer because the region is the factor that has the order. As you can see here, it has the age, it has the northeast, and other, which is the south, although we are going to test it against the age and non-chrome. So I did this over here. I assigned region as an integer variable, and I also assigned I also made age to be so unique, and non-chrome to be so unique, and region also was so unique. And running that, so the summary of our region here gives the variable that we have northeast, others, and west. We have 834 of northeast, 1614 of others, and we have west as 798. So in this case, we see that the mode value belongs to the other data type. So coming to age now, age. I need to do the summary of the age so that we can see the mean, median, and mode. So right here, I have the minimum value to be 6.500, the first quarter at 6.900, the median at 7.300, and the mean at 7.402, third quarter at 7.800, and the maximum value is 10.900. So let's do the same thing for non-chrome. So for non-chrome, it's different from the one we had before. So we have 0.00 as the minimum value. There's no minimum value. And the first quarter as 1.00, the median as 1.00, and the mean as 1.542, third quarter as 2.00, and the maximum as 8.00. So we go ahead to find the standard deviation for each of those variables. So the standard deviation for age is 0.633405. We see that that is kind of very close. It's further away from 1, but it's still a good result. And standard deviation for non-chrome says 1.34962. So I was able to say that the age variable has a lower standard deviation than the non-chrome variable. This is an indication that the value of age is more closer to the mean than the value of the norm chrome. So the mean, if you look at the mean very well, you see that the mean is the value of the mean here is 7.244, 7.402 for mean of the age, and the standard deviation of age is 0.633405, which is very far away from the mean value. And also the summary in the mean value for norm chrome is 1.542, and the standard deviation for norm chrome is 1.349. It is a very close value to the mean value. So this is an indication that the value of age is more closer than the mean of the norm chrome, which is the farther away from mean with scattered points. So the farther away a value is from the mean, it gets scattered, and it is not as close as it is at the other value to the mean value. So this indicates that the health of this population has more to do with the norm chrome than the age of the people. So this value is telling us that the age of the people does not really determine the health of the population of the people, like norm chrome would determine the health status of the people. So I was able to plot the graph right here, you see. Okay, while we are waiting for that to load. So question 4 here says that we should separate the data set into 25% training data and 75% test data. Then prepare the training data to run with two of the classifiers below. I was able to choose the classifier of tree and random forest. So for the tree here, we have to separate it first, and that's what I did here. I partitioned the whole data set into first 75% and the other 25%. The first 75% goes to the train, and the second 25% goes to test. Now from here, I was able to find the dimension of the final train value and the final test value, which you can see those. So after the partitioning, and the dimension came out as 13370.19 for the dimension of the train in 75%, and the dimension of the test for the remaining 25% comes out as 1.035 and then 19. 1.039 for the value of the object and 19 variables, and the other one says 3370 for 3370 for the value of the object in the train and in 19 variables. So we move over to plot the tree, and to plot the tree we have to get hold of the tree package, and that's what I did here. And I cut it into memory from the library, and I assigned a formula for me to work with to get the required tree value or tree diagram that I need for my data set. So oh, come on. Error mode of it should not be an error. I already did this, and it was quite okay when I did it. Let me run the tree package. All right, I believe it's correct because I already got his answer quite well. All right, so the summary of the final tree is this. I have the classification tree, and add add, div, and numcrom, and the terminal nodes are 4. Residual mean deviance is 1.124 to 3,794, 3,759 over 3,344, and the miscellaneous misclassification error rate is 0.2046. Now let's plot the final tree and see what we come out with. So you can see here that our tree has 3 major parts, and the others are listed accordingly to show the relationship that exists between them. It grouped them together. Others are grouped together to determine the numcrom and the hard-leaf value. And we see the hard-leaf value is less than 0.5 and the numcrom is less than 1.5. So there's a better relationship between hard-leaf and other variables in the others of the variable in HLTH. So now we predict it and we came out with this. Voila. Okay. So now the next thing I did here was the random forest, and in this random forest I was able to install the package, as you can see here, and I was able to, because I want to determine the clusters that exist between these variables. So come with me as we discuss this as well. Come on, guys. Okay, so this is what I need here. The value of the random forest, as you can see here, the number of trees that were generated is 500. It divided the entire data set, over 4,000 data sets, into 500 trees, and the variables tried to for the split. The variable split is 4, and we have the OOB estimate of error as 20.07. That's small, but not quite small. And we have excellent, other, poor. Okay, let's do the confusion matrix to determine the prediction and the actual value. So here, what is going on here? Okay. Well, I was able to come out with this analysis. Our prediction seems correct with corresponding value in the first classification. The value of the confusion matrix gives positive relationship in the references value gives the same value to the predicted value without any misclassification in the first confusion matrix. Thus, we have the highest accuracy possible because there was no misclassification from the first value, so our accuracy was 100%. So in the second classification, there are misclassification errors, which drops the accuracy level into 80% as against the 100% we have from the first classification. Therefore, we can say the classification makes sense because there is a significant relationship. There's a significant relationship between the variables in a similar vein. The first classification does not make sense because excellent, poor, and other cannot be of equal value in any given community. So the next question took us down to make a cluster, and the cluster I made here was the k-means analysis. No, I didn't make the k-means analysis. It was the k-means, okay, the k-means analysis and the db scan, as you can see here. And the best cluster in this is the db scan cluster that I was able to come up with. It shows that while population increases, the quality of health remains constant. This does not make a good sense at this time. Population will always increase, and the more the people increases, there may be the reason for